Hey folks, hacking this and that, back again with another video. And today we're going to talk sensors. Enough of that other nonsense. Um, so, in particular, if you haven't figured it out, we're going to talk about some Dragino door and water leak sensors. But before we get into that, I have my coffee and my stroopwafel. Thank you, Dumpling Girl. Um, and we can get into things. So, The the first thing I want to cover, and I've kind of touched on this on the Discord, is the LDS01. That's the door sensor. Um, so this is still partly disassembled. The LDS01, looking at the internals, my lids right here, um, and I've been using this one for a little over a year. Obviously burned through the battery, and I was like, there's got to be a way to get better battery life out of this. So I grabbed, what is this, a 3.7 volt, 550 milliamp uh, LiPo battery. Uh, Changed the connector on it because I actually wanted the smaller connector for a higher capacity battery for my mapper. And this is a JST 2.0 connector on here. And this is actually plugged into the JTAG header on the board. The two pins closest to the read switch are actually a VDD and ground. So get your polarity right, and you just changed from a coin battery, which typically has about a 200 to 250 milliamp hour, depending on the quality um, of your battery, and I've essentially doubled that. So, um, according to the specs, I should get 4 years worth of usage out of this, depending on spread factor and data rate. Um, so that's my door sensor. It's going to go back in hopefully this weekend. Um, and this is, again, the water leak sensor. Now, some of you are probably looking at that going, but it looks exactly the same, Peter. That's because they are. It is essentially the same brain. If you look carefully, you'll actually even see the read switch still attached to the board. Um, and what I've done with this one is I'm trying to install this on a flat roof and monitor how much standing water is sitting on that roof. So, in order to do that, um, it was for the last year doing that, but it was in a Tupperware container in a Ziploc bag taped up. It was the most hacky looking thing that you've ever seen. So I went to Home Depot and I picked up an electrical box, some uh, conduit, and this pass-through connector on the end. And you'll see what I'm trying to do here is put the probe in here and set that to the desired height because flat roofs are allowed to get wet. They're allowed to have standing water on them as long as they don't exceed the height of the membrane. So I'll determine my height of allowable water, and then as the water passes through here, it will trigger the sensor. So what did I do to get to this point? Obviously, I put a longer chunk of wire on here, but let me back up and go, where can you get these sensors? This is actually one of the cheapest entry points in helium sensors that you can get into. So you're looking at the LDS door sensor is $25 Canadian, $20 US, give or take, depending on where you buy. Can't get much cheaper than that. Throw in a couple of batteries, and you should be good for 17. Let me see if I got that handy here. 12,000 uplink packets off of the LWS01. The LWS02, which uses a pair of AAA batteries instead of the coin battery, should be good for 70,000 uplinks on your batteries. So while I'm in the process of doubling my current sensors, if I was using LWS02s, I should get closer to 4 years out of the battery swaps that I'm doing. So whether it's something small like a 550, or you figure that you're going to be seeing a high level of traffic, because again, every open close will trigger an event. Each event requires power consumption to transmit. You could go all the way up to something like a 2000 milliamp hour, again, JST 2.0 connector, and away you go. What else do I want to cover on this? Firmware configuration. So on these, that JTAG where we put the power, you can pick up one of these adapters. It's basically a small 6-pin JTAG compatible to a larger ribbon cable breakout, and that literally just slides on there. Now you want to measure out with a resistance voltmeter or continuity check to make sure you're figuring out which pins connect to which pins, and then relabeling it so that you can match up to the pins on the programmer. And then you can get in, you can do diagnostic, you can do some configuration. What kind of configuration can you do with these? There's two things you might want to look into, and my application, I don't intend to do either of these at the moment, but the mode function allows you to turn this between a door sensor, i.e. read the read switch, a water leak sensor, read the solder pads, or both. Now what I don't know is if it's going to treat that as a single input or dual input. So that'd be something for somebody to experiment and let me know. The other thing that you can do with this, and it's easier to do actually in the LWS02, is create an alarm state. And with that alarm state, what happens is if the door is held open for a duration of time, you can then fire off a separate alarm. So that is the LWS01, LWS01, yeah, door, water, surprise, DW, and how I am currently using these. This afternoon I'm going to take a trip to the site and install this, and I will do a quick field video, add that to this video, and show you how I'm putting these into use, and hopefully give you some ideas for your projects. Anyway, that's all for now. Again, I will loop in a clip of me out in the field setting this up, but until then, you can catch me on the Helium Discord, hacking this and that. Feel free to reach out to me with questions or ideas about your projects, and I'd be happy to help. Until then, good luck with your project.
All right, here we are up on the rooftop, and as you can tell by the clouds above me, there is rain imminent, so that's kind of why I wanted to get this done. This has been a sort of ongoing problem with this particular building for a while, and just making sure that we monitor and control the amount of standing water that ever settles on this flat roof. So let me show you what we got here. This is one of the HVAC units that actually sits over top of back there, one of the drain heads. The ratchet straps, trust me, are not serving much purpose. I'm not even sure why they're still on there, but not my problem, as they say. Anyway, here is the project. This is a Dragino LWS01 water sensor in a external housing with a battery expansion. I got this idea from all the hotspots I do, taking an indoor hotspot, putting it in an outdoor housing, and leaving it out in the Canadian winter. So down here, made one additional modification to the T-connector there. I drilled a couple holes in the bottom just so that water could drain out, and basically I'm just trying to make sure that I don't have a lot of standing water. So while I do have a gap under there, my concern is how much water is standing on this roof. So a little hot glue to hold everything in place, and put some covers on here, and we should be good to go. So that's my adaptation on the LWS01. Like I said, this can be done with an LWS02, even if you take the LDS01 or 02 and make that switch in the firmware. You can use that as a water sensor as well. And this is, yeah, that's all for now. I will possibly follow up later with some additional information on sort of the program automation that I built for this particular sensor. But for now, that's all we got. And we'll sign off for today. Have an awesome day, and good luck with your projects.